Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in our series of hypothesis testing, now we are working on two-tailed test. In this, we have an example. A laptop manufacturer claims that their new model provides an average battery life of 10 hours on a full charge. They randomly select 10 laptops and fully charge them. Then they record how long each battery lasts under normal usage conditions. Okay, dear students, in this situation, look, what is the mean? What is the hypothesis? We have the null hypothesis. We claim the normal claim that is the mean is equal to 10, but alternative hypothesis, the mean not equal 10. Our mean does not equal 10. Okay, so mean does not equal 10. Okay, in this, dear students, we have two-tailed test. Why? Because when you say the mean does not equal test, equal 10, it means the confidence interval is in between, and you are rejecting just in two sides. We have two tails and the significance level, or you can say the critical value that comes in both sides. So in this situation, dear student, first you should find out what is the mean value. So equal sign, you should type average and take the average of the battery hours, and we have 9.99. In the standard deviation, for the standard deviation not s, just take this function. Okay, we have standard deviation. Okay, for t-test, we are using two informations. One is significance level and a degree of freedom. So we are interested in 0.05 significance level. So since it's t-test, keep in mind that 0.05 is divided in two. That is just giving you for the significance level or the critical value for two tails, or you can say for two sides. And the degree of freedom, we have, since we have 10 samples, the degree of freedom is 9. Okay, from this data you can find out what is the critical value. Okay, so once you have a critical value with you, this is a critical value simply. Okay, okay, just go into the t distribution in 0.05 and check the degree of freedom 9. So keep in mind this is the alpha level, which is the 0.055%, but in two-tail test you should just search out 0.05 over 2. It means 0.025. So 9 into 0.025, simply 0.9. Here we have t-test, and 0.025 in the 9 degree of freedom we have 2.262. 2.262, dear students. Okay, 2.262 once again. Yes, 2.262. Okay, and now you should find out the t value. I'm just using this function. So equal sign, we have x bar, which is a mean value, and minus the mu, which is the hypothesized mean, which is 10. Okay, simply, and should be divided by the standard deviation, which is 0.366, and this should be divided by square root of sample n we have. Okay, let's close the bracket and press enter. We have minus 0.08628. Okay, dear students, in the critical value is 2.262, but since it's the two-tailed test, it's mean in the critical value we just find out the value for one tail, and the tail is symmetrical. Look, this shape is symmetrical, so if you find it in one area, and this is also equal for the another area, so you can say that the critical regions is not only 2.262. You can say the critical value, just to compare here, is the critical value that is somehow, you can say, between minus 2.262, right, and or you can say positive 2.262. Okay, what does this mean, dear student? Since the t value is in this range, okay, in two-tailed tests we say the mean does not equal. So if the t value is either less than the minus 2.26 or more than 2.262, the critical region, then we are rejecting the null hypothesis. But in our situation, this t value, this lies in between the range. Okay, so you can say since the t value lies in the range, we fail to reject the null hypothesis. Okay, simply. Why? Because the t value is neither less than the minus 2.26 in one extreme nor bigger than 2.262 in the right extreme or in the right tail. So that's why it is just in the in between. So in the area of confidence interval are 95%. So that's why we fail to reject the null hypothesis. Okay, this was two-tail test. Hopefully, dear student, this is clear. Okay, let me just show you in the graph. For example, this is the normal distribution. Okay, and here we have the central value is here. This is central value, and since it is two-tail test, right, so we have two critical values. Okay, this is the critical value, this is the region, this is the p-value or the probability. Okay, you can say this is the area of 0.025. Why? Because the 0.05 should be divided by 2. This is also 0.0 and 25. So you can say the central value here is that is 10, right? And the critical value in this point, the critical value, dear student, that is minus 2.62, right? And in this critical region we have that is positive 2.26. Okay, so you can say this value, this is in the range, the area of 95%, you can say. So that's why we cannot reject the null hypothesis. So if it lies either here in this range, below this critical region, critical value, or above this critical value, then you can reject the null hypothesis. Otherwise, you cannot, or you can say we fail to reject the null hypothesis. Assalamu alaikum wa rahmatullahi wa barakatuh.